In this video, we're going to talk about functions. We'll go over what functions are and how to evaluate them using various inputs. Essentially, a function can be thought of as a machine that takes an input and gives us an output, meaning we can plug something into the machine and we're going to get something out from it. Like variables, we denote functions using letters. But instead of using letters like x, y, or z like we do for variables, we typically use letters like f or g for functions. Oftentimes, we use a picture of a machine with funnels like this as a visual representation for a function. The funnel on the left is where we can plug things in, so this is where our inputs go, and the funnel on the right is where the outputs come out. When working with functions, we use a specific notation for the outputs of a function. We write f of x to denote the output of the function f when x is input into the function. This is called function notation. So, for example, if we take the number 2 and we plug it into the function, then the output that we get we will denote as f of 2. As another example, if we plug in a number like -3 into the function as the input, then the output we would denote as f of -3. We can plug in other things other than numbers. For example, we can plug in letters or symbols. So for example, if we plug in star as the input to our function, then the output to the function will denote with f of star. We often use functions to denote a series of operations that we want to perform. So those operations are what's going on inside the machine once we plug in some input. To specify what a particular function does, we tell you the output of the function when we input a variable x. As an example, let's consider this statement. Let f of x equals 2x minus 3. Now what we're doing here is we're telling you that we have this function f, and we are telling you that the output of the function f is 2x minus 3 when we plug in the input x. So essentially this statement tells us that no matter what our input is, we're going to do 2 times our input and then subtract 3. That's how we get our output. Now that we know what the function does, we can figure out the outputs of the function for various inputs. For example, what we can do is we can evaluate f of 5, meaning figure out what the output of our function is when we input 5. If we go back to how our function is defined, we're told that the output of our function when we input x is 2 times x minus 3. For that reason, if we input 5 into our function, we would be doing 2 times 5 minus 3. When we compare f of 5 with f of x, we see that we're inputting 5 into our function instead of x. So to get the output, we take the formula here, 2x minus 3, and we replace the x with 5. Now all we have to do is perform these operations. 2 times 5 gives me 10, and then 10 minus 3 gives us 7. So this tells me that the output of my function when I plug in 5 is 7. In our next example, we want to evaluate f of -4, meaning we want to find the output of my function when I input -4. Again, from the definition of the function, we know that when we input x, the output is 2x minus 3. So doesn't it make sense that if we input -4, the output would be 2 times -4 minus 3. So once again, we're basically using this formula 2x minus 3, but instead of having the x here, we replace it with our new input. So now if we want to figure out the output, we just have to perform the arithmetic. 2 times -4 gives us -8. If we then subtract 3, we get -11. So the output of our function f here, when we input -4, is -11. For our last example, we want to evaluate f of a. This time our input is a letter rather than an actual number. But it turns out that everything works the same way. If we input x into our function, the output is 2x minus 3. So doesn't it make sense that if we input a into our function, the output is 2 times a minus 3? Once again, we're just looking at this formula for the output and we're replacing the x with our new input. Now the expression 2 times a minus 3 can't be simplified any further, so that's our answer to this problem. Let's get some more practice with a different function. In this example, let g of x equals x squared minus 3x. In this example, we're working with a function whose name is g, and we're told that if we input x into our function, the corresponding output would be x squared minus 3x. Now, with this function, we're asked to evaluate the following, meaning we want to figure out the outputs when we plug in various things. In example A, we want to evaluate g of 1, meaning what's the output when we input 1 into our function. According to how our function is defined, if we input any number x in there, the corresponding output would be x squared minus 3x. So if we input 1 into our function, the corresponding output should be 1 squared minus 3 times 1. Basically, everywhere we have x in the formula for our function, we're replacing with our new input 1. So now simplifying this, 1 squared minus 3 times 1 would be 1 minus 3, or negative 2. So for this problem, g of 1 is negative 2. In part B, we want to evaluate g of 2, meaning what's the output of my function when I input 2? So we can go to our formula for our function, x squared minus 3x, and everywhere we see x, we're going to replace with our new input 2. So that's going to give us 2 squared minus 3 times 2. 2 squared gives us 4. 3 times 2 gives me 6. So 4 minus 6 gives me, once again, negative 2. So when we evaluate g of 2, we get negative 2. Next, we want to compute g of negative 3. So once again, we go to our formula for our function, x squared minus 3x, and everywhere we see x, we're replacing it with negative 3. So this is going to be negative 3 squared minus 3 times negative 3. Computing negative 3 squared, we get positive 9. And then if we do negative 3 times negative 3, we get another positive 9. And so 9 plus 9 gives me 18. So the output of my function when I plug in negative 3 is 18. In our next example, we want to evaluate g of star. This time, our input is not a number or a letter. It's just a symbol, but it works the same way. We go to our function. The formula is x squared minus 3x, and everywhere we have x, we're going to replace with our new input star. So what we're going to get here is star squared minus 3 times star. Now we can't really simplify this any further, so that's our answer. In part E, we want to evaluate g of 2a minus 1. This time, our input is not just a number, it's not just a letter, it's not a symbol, but a whole algebraic expression, 2a minus 1. If we want to find the output, we just repeat what we've been doing in our previous examples. We go to the formula for our function, x squared minus 3x, and everywhere we have x, we're going to replace them with our new input, 2a minus 1. So our output is going to look like 2a minus 1 squared minus 3 times 2a minus 1. One thing to note is that it's important to have these parentheses around my 2a minus 1s. Whenever you make a substitution, like replacing these x's with something that has multiple terms, you need to put parentheses around your expression in case you need to do operations like squaring or distributing. Now, with our expression here, we can simplify this further by multiplying out the 2a minus 1 squared and then distributing the negative 3. To multiply out 2a minus 1 squared, we want to think about this as 2a minus 1 times itself. And here, we're going to use the FOIL method to multiply this out. The first terms, 2a times 2a gives me 4a squared. The outer terms, 2a times negative 1 gives me a negative 2a. The inner terms, negative 1 times 2a gives me another negative 2a. And then the last terms, negative 1 times negative 1 gives me positive 1. So simplifying this, we have 4a squared minus 4a plus 1. So for our function here, the 2a minus 1 squared gives me 4a squared minus 4a plus 1. And then if we distribute the negative 3, we end up with minus 6a plus 3. We can then combine some like terms. For example, the negative 4a can be combined with the negative 6a. The plus 1 can be combined with plus 3. So we end up with 4a squared minus 10a plus 4. And that's our final answer. That's the output of my function when I input 2a minus 1. In our next example, we have 2 times g of a minus 1. Here, we're not just computing the output of a function, we're also performing some operations on the output. We're doing 2 times the output of my function when I input a, and then subtracting 1. To evaluate this expression, essentially all we have to do is replace this g of a with the output of the function when we plug in a. So we're going to get 2 times, now g of a means that we're going to take x squared minus 3x here and replace the x's with a's. So this is 2 times a squared minus 3a, and then subtract 1. To simplify this, we'll distribute the 2. This gives us 2a squared minus 6a minus 1. And that's our final answer. For our next example, we want to evaluate g of x squared, meaning what's the output of my function when I input x squared? Just like before, we go to the formula for our function. It's x squared minus 3x. But we're going to replace these x's with my new input. The input is x squared. So everywhere I had x's, I'm going to replace them with x squares instead. So our output is going to look like x squared squared minus 3 times x squared. Simplifying this, if I have x squared squared, basically we're doing x squared times itself, we'll end up with 4 factors of x, so this is x to the 4th power, and then minus 3x squared. So g of x squared is x to the 4th power minus 3x squared. In our next example, we have g of x squared minus x times g of x. So again, we have a complicated looking algebraic expression, but all we really need to do is replace the g's with their respective outputs. The g of x squared we found from our previous example is x to the 4th minus 3x squared. So let's replace that first. G of x squared is x to the 4th minus 3x squared. Then we're subtracting x times g of x. So g of x is the output of my function when I input x, and that's given to us from the very beginning. The output of my function when I input x is x squared minus 3x. So we're going to write down minus x times g of x we replace with x squared minus 3x. So let's simplify this. We can distribute the negative x here to get x to the 4th minus 3x squared minus x cubed plus 3x squared. If we combine the negative 3x squared with the plus 3x squared, those two terms cancel out, and we end up with x to the 4th minus x cubed. And that's our final answer. In our last example, we have g of x plus h. Just like all of our previous problems, if we want to figure out the output of our function, we go to the formula for the output, which is x squared minus 3x, and we replace the x's with the new input. So g of x plus h is going to look like x plus h squared minus 3 times x plus h. For now, we won't simplify this expression any further. We will in the future when we talk about difference quotients. So in this video, we've learned about functions and we learned about how to figure out the outputs of the functions when we plug in various inputs.